Okay, so I guess next will be the presentation on the COSMIC, which is, as the title implies, Cosmos Interconnecting Continents. And this is going to be the sort of talk about how we are trying to expand the reach of Cosmos across the oceans. So just a very quick introduction, and most of you have heard this talk before about the Cosmos itself, right? So the idea is to sort of create this city scale deployment that covers the edge computing elements, as well as focuses on real-time applications, which means low latency, high bandwidth type of things. And the main enablers for that we believe are critical for implementing that are the millimeter wave devices with high bandwidth capabilities, lots of dark fiber deployed in the West Harlem in New York City, and of course remote access and programmability everywhere, which means that we are focusing on fully programmable elements in both wireless and wired sense, right? And so the Envisioned deployment is shown in this figure. So it's, as I said, West Harlem in New York City. It extends approximately from 120th Street to 135th Street, and then Broadway and Amsterdam Avenues, right? And the idea is to deploy 9 large sites and about 40 medium sites. When we say large, that typically refers to rooftop deployment with multiple sectors, and then the medium nodes are what we call the street level nodes that are deployed either on the sides of the building or on the lamp posts, and some number of small portable devices, or near portable as we jokingly call them, because these are software defined radios that you probably need 2 hands to carry around. The implementation is in phases. We are, of course, due to COVID, now quite behind on our phase 1 implementation, but hope is that we will soon have our city college deployment commencing with the installation of the nodes. As I said, there is a lot of dark fiber, and in addition to testbed deployed dark fiber, we also have, and it's shown here on the left, extension of fiber to 32A of A. 32A of A, 32A Avenues of the Americas is one of the largest carrier hotels in the world. And we have optical presence as well as some equipment in that carrier hotel, which allows us to connect to a really wide range of services and providers and reach connectivity around the world. So now, as I said, the focus is, among other things, on optical technologies, and in context of COSMIC, this is actually a critical component. In core of it is this massive space switch, which is the MEMS device from Caliant, that allows us to sort of have this fully programmable topology of optical connectivity. We do have a lot of other optical elements, including a large number of ROADMs that can be used for additional configuration and switching and optical switching, and essentially allows us to sort of create a fairly interesting optical testbed. And that is, as I mentioned, critical for the COSMIC. Now, looking at the big picture, this sort of shows a very busy Cosmos wide area connectivity configuration. As you can see, there are a lot of fully programmable, both P4 and SDN, traditional SDN wide area transport switches that are interconnecting various components. Of course, the core is on the lower left-hand corner of the diagram, where we have the Cosmos core and orbit in WINLAB. And then in the upper left, we have the 4 elements of the Cosmos that are in New York City, including NYU, Columbia, and City College. And then, of course, Silicon Harlem has a non-trivial deployment of computing elements. And we are in the process of actually interconnecting it with the fiber to the core of the COSMIC. And again, 32A of A in the context of COSMIC is really the focal point should be focal point of this diagram. There we have both P4 and SDN switch deployed, and as you can see, have connectivity to quite a large number of research networking providers, Internet 2, Sienna, NiserNet, and ESNet cores. And of course, a lot of commercial providers are available in the 32A. Now, we have the COSMIC itself is really focused on interconnecting a fairly large footprint, in other words, spanning Europe, Japan, and Brazil, in interconnecting a large number of testbeds, both wireless and wired testbeds that exist on these continents. And this sort of shows you the elements or sites that are part of the deployment. The additional capability that is introduced is that we are partnering with peering effort that's been going on for quite a while now, led by Columbia collaborators, which also gives us reach to a lot of other places, not just the ones that are listed here. Now, looking at how this looks like, and this is a fairly busy diagram, you can actually see all the capabilities that are sort of listed here. So pretty much every place has more or less a cloud deployment of some kind, and then a lot of networking gear at various places. And again, we do have connectivity either on layer 2 or layer 3. And all of these testbeds allow us to sort of really, really expand the networking footprint and keep programming capabilities that we have in Cosmos. Now, looking to our particular partners, so there is a collaboration between CCNY and QTech in Japan, and this is done under the NSF umbrella a program called Juno 2, and it's focused on resilient edge cloud, right? And they actually also have some security experimentation that's been going on. And again, the idea is to sort of try to figure out how to expand the experimentation that comes that's part of this effort. The second one is CPQD in Brazil. And again, there, the idea is to sort of have the SDN lab that's part of the CPQD connected to the Cosmos as a sort of optical testbed, and to look at sort of interconnecting and doing experiments on much larger scale that are related to SDN capabilities. As I said, we are federating with peering, and that will probably happen in various places, but most notably in 32A, where peering has a strong presence and it's connected to a number of different testbeds. And the main feature of peering is the ability to play with BGP and sort of do all sorts of experiments, both on isolation between different BGP planes, as well as on sort of even security aspects of BGP, and running multiple completely disjointed broadcast domains, or sorry, DNS domains, and doing experimentation with that. Now, as far as peering is concerned, right, so it's connected to a very large number of other testbeds, which of course gives us now ability to expand the footprint of COSMIC even further. And again, really the focus is to sort of connect this on the layer 2 and expand the capabilities of other testbeds that are participating in COSMIC to sort of, again, start using peering as a platform to do a much larger DNS experimentation. As part of collaboration with our friends our collaborators in CPQD and Ireland, we are working on expanding Mininet with the optical support, and we actually had a talk a couple of weeks back by our collaborators from Ireland. We had a WINLAB seminar that you can see on the WINLAB YouTube channel that sort of tries to build the optical version of Mininet. And the idea is to sort of use the existing capabilities of Cosmos and this new COSMIC to sort of collect a lot of data that will be used to sort of drive the data models that are part of the mininet. And of course, look at other testbeds that are part of COSMIC and try to collect and further improve the quality of the data that will be used to manage or to model the mininet. So think of it as a digital twin type of effort, building digital twin type of effort. Now, as the X experiment in COSMIC, so there is actually a collaboration that's ongoing and where COSMIC will be used to sort of look at this really complex SDN-based configuration where physical impairments will be used to sort of drive the network management, if you want to call it. And again, this is sort of the fact that this is a multi-domain environment actually enables a fairly interesting platform for experimentation in sort of understanding these impairments and how they can be used to improve routing decisions. So I'm not sure, Ray, do you want to take over here and talk a little bit more about experiments on the low latency stuff?
Hi, so I think Ivan, you can finish off this because we don't have too much time. You have the slide up here.
Sure. So actually I have a couple of slides and so this is essentially the extension of the previous work that was done on AAR, right? And you can sort of edge-aware interdomain routing protocol, right? So this is the work that we've been doing, that's been going on for a while now. And it sort of looks at the ways of sort of extending sort of traversing the networks without revealing too much information for individual domains, right? And but still allowing some sort of a notion of quality of service and among multiple routes to be exposed to the end user applications. Now, this is the experiment that will be sort of designed on top of the platform, and the assumption is really that there is this service migration across a fairly large distance, and this particular network would then be used for facilitating such an experimentation, right? And again, the idea is you have visitors moving across and you need to transfer their services. Now, there is an experiment plan and we are trying to sort of do that. So I just, in the interest of time, I'll sort of finish here with the really important component of the COSMIC, same as it is for Cosmos, and that is to look at the education and outreach and sort of try to sort of extend this to cover both COSMIC and peering capabilities and to try to educate people about the capabilities that can be experimented with as part of this. So in summary, right, it's actually connecting fairly interesting number of global wireless, optical, and IoT testbeds. The idea is to sort of increase or enhance capabilities for each of these or some of these testbeds, and to sort of run a number of experiments on top of it, and then of course to try to educate a larger community and enable teaching by using some of these platforms. So that's pretty much it for the COSMIC, right? And so now I guess I have to again jump in and start talking about the yet another effort on the testbed level. And let me just switch the slide deck. Okay, so start sharing. So do you see my slide deck?
Yes.
Okay, so let me see if this works. Yep, there you go. Okay, so now I want to sort of start talking about the effort that's been going on for the last 5 weeks and consuming quite a lot of our resources, which was, of course, nice, given that we had a pandemic and for the last almost 2 years, right? And this was sort of an interesting change of pace and quite a lot of people coming into the lab, not all at the same time. Over the last 5 weeks, and so the whole idea is that there is this sort of initiative for 2 of the power platforms to become what's called the OTIC, and OTIC stands for ORAN Test and Integration Center, right? And before formally making that happen, what we ended up doing is sort of hosting what's called the ORAN Plugfest and Proof of Concept effort, and so this is, as you can imagine, a fairly large number of people were involved in all of this. And I'll be talking mostly about proof of concept part. Of course, as you can imagine, there is a lot of information that is sort of only available to the ORAN Alliance members, and I'll try not to talk about that. But, I will definitely give you more details about the proof of concept. So let me just start by saying that as I said, a lot of people were involved in the proof of concept, and here's the list of names. I'll just sort of briefly touch on the history of our involvement in these various efforts to testing. So it all started in about 2016, when Orbit was hosting the proof of concept by the ONAP community, or open networking stuff by the Linux Foundation. And the focus of the talk was really on millimeter wave models and sort of multi-vendor environment. And you can actually see this was the good old days when everybody would come to the lab and interconnect their equipment and do a real true plug fest. Now, one of the reasons why we were approached by AT&T and other operators is the fact that Cosmos has the experimental license FCC innovation zone designation in the New York area, and then also all the institutions that are part of Cosmos have what's called the program experimental license on their campuses, which of course means that we can do interesting experiments using a fairly streamlined approval model by FCC, right? And you can actually see here the frequencies that are allowed, which of course it pretty much covers everything that people have interest in these days. And then over these last 4 or 5 years, we actually established the permanent experimentation platform that ORAN and ONAP communities are using, right? And you can actually see here, it's a fairly sizable cloud-based setup. We have currently 22 fairly beefy machines that are part of it. 6 are what we call the control nodes, and 16 are compute nodes. And these are essentially 3 OpenStack environments, namely stable, development, experimental. And you can actually clearly from the names figure out what's they're used for. The idea is that the stable one is used for POCs and plugfests. The developmental one is used for actual development, and the community is actively using it. And then experimental is sort of left for individual experimenters to try things out, and it's sort of wiped out daily. Now, additionally, there are a lot of on-demand resources that are part of the Cosmos and Orbit testbeds that people can use, but those are sort of on-demand and first-come, first-served type of resources. In other words, they're not permanently assigned for the ONAP and ORAN communities. So talking about the last 5 weeks, right? So the ORAN Plugfest and Proof of Concept. So Plugfest, just as sort of a quick explanation, Plugfest is literally what the name implies. People bring their equipment, connect it together, measure performance, or figure out if they have interoperability, right? Proof of concept is sort of referring to new and interesting ideas that are being pursued by the community in order to point out what are the functionalities and interesting features that community should be developing, right? And so every 6 months or so, community comes together and does these joint plugfest and proof of concepts. And we are now in the 2021 in the plugfest number 3, right? And this was hosted by Verizon and AT&T. And in North America, and this is happening around the world, of course, but in North America, this was executed in 3 places: in TIP Community Lab at Meta in Menlo Park in California, at University, and the 2 power sites, the Powder Lab in Salt Lake City and Cosmos Lab in New York City area, right? And so, of course, as I said, I'm not going to talk about the plugfest much, but to say that this is sort of a third in the series, as I said, and you can actually see that the number of tests is growing significantly, and more importantly, a number of participants, at least in terms of North America, is really growing up significantly, despite the restrictions that COVID placed on things, right? This is the list of companies that participated. You can actually see that pretty much everybody was on the list. Now, I have to introduce as I said, I'll focus mostly on POC. And in the context of this particular effort, have to explain 2 most important aspects of it. And that is the polling, right? Polling, which is sort of grouping together resources from multiple operators and vendors to sort of expand the capability of the network. And just put this in the context of, say, disaster scenario where each of the vendor operators loses some capabilities. If we can pull together jointly their resources, maybe we can recover the network capabilities, right? Slicing, on the other hand, is sort of an effort to sort of carve or put together support for a particular case, and sort of in a disaster scenario, say, provide capabilities to first responders dynamically based on their requirements, right? So in other words, slice the network or elements of it to support mission critical type of thing. Now, in the ORAN context and ONAP context, right, assumption is that even though this is a multi-vendor, multi-operator environment, right, we can come up with the sort of smart way of doing this. And this is where putting all these both pulling and slicing together, using the artificial intelligence to sort of automate the whole process. Otherwise, configuring networks is fairly slow and manual process these days. The assumption is that given the new programmability and disaggregation that ORAN and ONAP are providing, we can do that in an automated way. And so, just in the interest of time, I'll speed up a little bit through the whole thing. So, in normal operation, right, all the equipment is functioning. The user equipment is attached to the operator based on their membership or participation, right? And of course, you can have the AI support for various elements of the network, but it's all based on the individual operator basis, right? Now, in disaster, the assumption is that we can trigger this resource pooling and slicing. And of course, given that the situation is disaster, chances are not all the equipment is available. The handoffs are really just focused on providing support for, say, first responders. And then the allocation of resources should be driven by AI so that we reduce the time needed to get the network up and running, right? And just to illustrate, so like before the disaster, in this case, we have 2 operators, A and B, And the traffic is, each one of them operates their own network. Each UE is connected to their respective cores, and the networks are operating fine. Once the disaster happens, both operators lose some of the capabilities. The FEMA issues the request for a declaration of disaster, right? The management entities of both operators receive those requests, and potentially the public safety management issues the request for pooling the resources and slicing, and both of the operators sort of receive the slice participation commands, right, based on the AI, right? Now, the assumption here is, of course, that not all UEs will be able to participate. The priority is given to the important guys, to first responders, right? And but it's also implied that maybe parts of the network will be left for the operators to manage their own stuff if they're not needed as part of the public safety. So obviously a fairly complex environment. So, public safety slice grabs a set of resources, declares certain UEs as important ones, assigns resources to them, and ensures that quality of experience or quality of service is satisfied. Now, after the disaster happens, after the disaster is over, the resources, the public safety slice is returned back to the operators, and they can try to recover their regular usage, right? Okay, so AI, right? So crucial role in all of this is that given that the dynamics of the disaster is the role of AI in such a system. And of course, given that we have quite a lot of software-based capabilities, the AI has to be able to gather information about the resources, right? So whatever is the state of the environment, the AI helper or functions that will provide slicing needs to be able to talk to operators and gather information about the state of their networks. It has to determine the best course of action. Of course, that's the whole idea, based on user demands, and both regular users and first responders. And then, of course, it has to coordinate, implement the slicing and stuff. Now, how does it look like? So, of course, you have a public space. So the concept of SMO, or service management orchestration element, in part of ONAP and ORAN, right? Has to exist, and in this particular case, we are looking at number of SMOs, each vendor having its own SMO, and then the public safety SMO being sort of the umbrella SMO on top of it, and then intelligent agents sitting on the sort of as part of the public safety SMO that's managing the disaster, right? And of course, the assumption here is that this is not fully self-automated, but there are humans involved, of course. But the idea is to sort of shorten and as quickly as possible react to the environmental feedbacks. Looking at the implementation architecture, right? So this is how it looks like, and just happened. Can you hear me? Oh, sorry. This is sort of typical small deployment sitting on top of open cloud, and you can see all the sort of the different protocols, but the focus is really on M-plane, open front haul, and associated models. And so this was fully implemented as POC, and I'm just going to rush through the slides. The footprint of the deployment is that we had 2 power sites, Cosmos and Powder, interconnected with the public safety SMO that was sitting in Fujitsu Lab, and IBM Cloud stuff in the AWS. And of course, this was really proof of concept, and it was amazing to sort of see that we could actually pull this off. You can see here sort of the state of slice status before the event. Public safety slice is inactive. operator slice is active. When disaster happens, some number of resources get lost. The slice status changes to public safety becoming active and operator individual sites inactive. And then, of course, at the end, it reverts back. So quite a lot of details are available on all these, both PlugFest and POCs on the individual websites. I just want to point out that this same POC was actually shown at the TM forum as part of one of the proof of concept deployments there. So this is where I would stop. If you have any questions, please feel free to post them on the chat or send them in the email.